Today, I will talk about superficial introduction to technical depth. Then I will try to convince you to use entity framework, TypeScript, SASS, a CSS framework, and other things if you are not already doing it. I will try to give you concrete examples from my and my team's projects and sprinkle in some additional techniques that help us with maintainability on the cheap. For example, T4 templates, VUEPRESS, basic examples of internal tools, and I will talk about Visual Studio settings. What is technical depth? Technical depth is the amount of time that needs to be spent on future enhancements to fix existing code so that the project is working perfectly. This chart captures the problem very well. The more we struggle with the existing solution, the less time we have available for developing new solutions, new features. The chart, as you can see, has no axis values. This makes it applicable for every software project out there. Technical depth can be of the following types: deliberate, like choosing to prioritize speed over quality; unintentional, because of bad design or lack of knowledge; unavoidable, for example, when a third-party library becomes outdated. 25 years ago, my father, with my help, built a stick welding machine. And this product is still being used after 25 years. Today, it performs its duties perfectly. But even this 40-kilogram steel cube with very little moving parts needs maintenance. It has a wonky wheel, and it has a switch that needs to be persuaded to work in a specific position. Software needs magnitudes more maintenance. And to answer your original joke, or as an answer to your original joke, in short, technical depth exists in all projects in different amounts, of course, and technical depth is bad, okay? Technical depth can be minimized by avoiding taking shortcuts, by using simple designs, continuous refactoring. It can be minimized through good documentation, good testing, etc. My team's project is 13 plus years old. It's an IoT solution. It's still ongoing and profitable for the client. The client is mindful of all the challenges and the time costs, and it is a pleasure to work with them. That said, we have far less maintenance periods than we would like. We are compensating with doing as much maintenance as we possibly can during writing the code, so we don't end up like repair boys. I will base most of my presentation on the techniques used in this 13-plus-year-old project. We are already trying to follow and keep to the best practices. We are aware that product development is an evolution. It's rarely stepping back. And because our project is 13 years old, we have even less opportunities to start things over. We stick to the best practices, but we always adapt to the situation. We avoid implementing something just for the sake of it. For example, DB context already implements a unit of work. It would be a mistake to complicate ourselves by trying to force a unit of work on it. We avoid abstractions when possible. We once burned ourselves by trying to implement a general helper. And we keep in mind that the best code is just plain boring or no code at all. All this is still not enough. So besides best practices, we apply any additional cheap strategy to reduce our maintenance costs a little bit more by trying to eliminate guesswork from programming, the human factor, avoid repeating tasks, and we avoid the manual testing as much as possible. Let's jump into this into the concrete tricks that we are using in our project and how we address these issues. For starters, I urge you to use code analysis on your projects with zero tolerance for warnings. .NET Core has built-in code analyzers. Additional ones can be added through NuGet. Code analyzers look at your coding style. They look at your code quality, and they display the results in the form of errors, warnings, or messages inside the error list, or through squiggly lines inside the editor. Years ago, this analysis was done by static code by a combination of static code analysis and standalone style extension. Code analyzers save us a lot of time. I really like when robots do the work instead of me, and this is the exact situation. This system looks at your code or our code and finds all superficial problems before a code review. This, in combination with automatic code formatting, allows the code reviewer to concentrate on what is more important. The strategy to set up code analysis is to set up code analysis and configure it to check for only the problems that are relevant to the team. Then the only thing that remains is agreeing with the team that the project is not allowed to have any warnings at all. Alternatively, you can set the treat all warnings as error setting in the project. So treat all warnings as errors in the project settings. And imagine how much time this approach shaves off from the onboarding of a new team member. If you're working on old projects, you can still add analyzers by selecting Add Analyzer from the project's context menu. If you have just introduced code review, a code analysis as part of the code review, and your project generated, I don't know, 5,000 warnings, I recommend ignoring them all initially, ignoring them all by using EDITORCONFIG, as I will describe it later, and only enabling them as they become possible to fix to avoid stressing the team out. There's a danger that the team will give up on the approach if they are stressed too much about code analysis results. Irrelevant code analysis reports are easily ignored by using EDITORCONFIG, attributes, or the Pragma preprocessor directives. And here we can see how to set a severity to a warning. Doing this the first time will create an EDITORCONFIG file, which you can for which Visual Studio 2022 already offers a visual editor, and I also like the old text-based editor as well, but that one did not have all the options listed, as you can see on this screenshot. T4 templates. In Visual Studio, T4 text template is a mixture of text box and control logic that can generate a text file. T4 templates are used within Microsoft for ASP.NET MVC for the creation of the views and controllers, Edo.NET Entity Framework for entity generation. There are two kinds of T4 templates. There are those that are run on that are executed on runtime, and those that are executed on design time. We are only going to talk about the design time templates. And below on the bottom part of the slide, you can see the markup, an overview of the markup that T4 templates use. Imagine them as PHP scripts, if you will. In general, we use T4 templates to avoid hard coding strings and desynchronization between code and documentation. Our application has a lot of resource files. For example, our application has a lot of resource files, and they need to be directly accessed by a resource reader. Before I go into the technical details, just look at, you don't have to read the screen, but just look at what's on the screen. This is a piece of T4 template that is saved into a separate include file. And this basically loads a resource file and generates all the keys from it. And then what is left to do is use it like this. It's a very simple usage. And this will generate C# code that contains the resource keys from the country resource files. After saving the TT file, that is the extension of the T4 template, TT, this is the result that gets generated. Notice that we had an XML file before, and from this XML file, we have received C#, strongly typed collection. And using the key and the file name properties of any resource pointer from here, we are going to be capable to go and find this file, this resource key, and load the resources from it. Here's an example where generated resource keys are used without hard coding the name of the resource file and the resource key. This is a basic usage where we take the file name, where we take the file's file name and the key, and of the entry, that is the localization, and declare our own resix reader and obtain this value. The second example is much higher level. It only needs the resource pointer, a nullable default value, so this could be null, empty, and the path to the resource file, where all the resource files are kept. Hoppa, no, I jumped too far ahead. I'm so sorry. I have to learn to use PowerPoint. So we were here. Okay. Another nice trick that you could use is to keep all your localization files in a central project and reference them when they are needed using add existing item and add as a link. This means that all localization files have to be, I don't know, created or kept in one single central place. Here's an overview, and I will explain it in detail. You need 2 domain projects, one to store the resources, another one to store the generated resource keys. These 2 don't even need to reference each other. Code generation works through relative paths, not project references. You don't even need 2 separate projects. And the darker project needs to reference the project with the pointers and link to the resix files from the other one using add as a link reference. As a disclaimer, it could be that we could have avoided this workaround that I have just presented if we could have made a global resource proxy generator work on linked resix files. This global resource proxy generator tool creates a strongly typed resource class. So in the project where you have these resix files stored, it already creates for you a strongly typed resource file. So I hope that we have chosen the good solution. But the idea is that our solution is useful in eliminating our hard codings. And if there are any problems, like a line got deleted from a resource file, they are found at compile time. This is the most important part that we are aware of the errors during compile time, not runtime. Another use case where we use T4 templates is generating the list of web pages in the project. For this to work and to avoid hard coding, we need access to the path of the project, for which fortunately T4 templates offers a solution. Otherwise, to load the contents of the folder, we must use a very hard-coded path that would not work between team members. But fortunately, T4 templates offers a solution. We are allowed to refer to URLs inside of our projects only through these generated results. This prevents us at compile time from trying to redirect to a page that is, for example, since deleted, or this avoids us making a typo in for example, when we want to redirect to accept privacy policy .html, we I don't know, omit the letter. This would make the redirection not work, but with T4 templates, you are avoiding this problem. The last T4 template use case I want to present is about documentation. We combine config files with database-based settings in our project. And the fact that we are generating classes to strongly typed database settings is already fascinating, but the documentation part is much better and simpler to explain. We have created a T4 template that gathers all configuration items from the project and from the database and outputs them as simple Markdown or HTML. This approach saves us a lot of time and prevents desynchronization between code and documentation, or setting values and the documentation. Did you know that neither config files nor settings editor allow you to add descriptions, but you still can add the description using the attribute, the description attribute of the settings file if you open it in XML editor mode. Here's the piece of the template's output. This is a simple HTML result that can be taken and copied into a wiki or a document, and it will take over the styles of that target document because it's just bare bones HTML without styling. And we usually use Visual Studio Code to generate HTML from Markdown. I'm sure there are better ways to do it. For us, the purest form of documentation is Markdown. When possible, we try to create all our documentation in Markdown form first, and it is very easy to generate other contents from it. To output HTML, for example, you can use Visual Studio Code, as I have mentioned before. However, you can take the code generation even further. Using the VUEPRESS static code generator, we can generate a single page application and upload them, for example, to GitHub pages, and we have a full website dedicated to your project's documentation. The only drawback we found with VUEPRESS was that VUEPRESS is not capable of serving files from the local file system. It only can serve the content from a web server. Our current workaround is rewriting the references in the generated output using a tool, a private tool of ours. Here's a snippet of the welcome page written in Markdown. Notice that the markup is both machine and user readable. And based on this piece of simple text, we obtain this output. The best demo is VUEPRESS's personal documentation website. Here's the welcome page, and here's the page of the internal documentation. Note the fully functional search, navigation, and language switching features. In summary, VUEPRESS gives us an amazing thing with very little time investment. CSS in WPF. This technique I want to show you fast is related to a WPF project, not our 13-year-old one. In order to reduce the guesswork when we are placing components on WPF forms, we borrowed an idea from old grid CSS grid implementations. The idea is that elements control their distances with paddings, and containers neutralize these left and right paddings with negative margins. This in WPF translates to all elements have, for example, a 5-pixel margin. All containers have a 5-pixel padding, and this results in 10-pixel distance from container walls and 10-pixel distance between each control. The main benefit is that in simple cases, there is absolutely no need to think about distances at all. So in order to do this, we have created a base style that defines a margin. It is now 5 in our case. This is the placed in the base XAML, and here is a usage of the base style in a labels definition, and here is the result. The benefit is that you can again just throw controls on a form, and they will automatically and beautifully keep their distances. Notice the vertical distance between all of them, how uniform they are, and the larger horizontal distances are caused by containers. For example, this COM4 and COMPORT distance is caused by here being a container, and the containers having 5-pixel margin. It works out beautifully. And the special cases like the distances over the connect buttons are handled with inline styles. This approach simplifies things and saves a bit of time as well. I want to urge you to use SASS in your web projects. SASS is a CSS preprocessor. Among other things, it allows us to use variables and reusable methods called mixins within CSS. And I urge you to use SASS, especially that all CSS files are already valid SASS files, so it's easy to convert your project. If you want to go into deeper, just look at the on the left, you have the SCSS code. It's basically a SASS file with accolades used. So there you can also use the SASS format where the file name is called, it has the SASS extension, but that version doesn't use the accolades. And you see we have created the primary color and font stack variables, and on the right you can see the compiled CSS that incorporates these declared values. And in the case of mixins are like functions or reusable pieces of CSS that you can use as you see it on the left, and it generates into or outputs into the CSS seen on the right. I urge you even more to use a CSS framework in your project. CSS frameworks contain CSS code that is standards compliant. Most CSS frameworks contain at least a grid, and more functional ones also contain JavaScript and other things like fonts and icons. There are many around, like Twitter Bootstrap, Foundation, Tailwind, etc. Choose one based on your needs. Besides an ORM, Twitter Bootstrap saved us the most time, especially if you are creating a web project from scratch. Just grab a framework, reference it from your HTML, and you have a good-looking website. You don't have to worry about how your web page looks in each browser or how your web page looks on a mobile screen. Of course, this approach has drawbacks and criticism. Using a CSS framework results in a same-looking website. Results in same-looking websites, and it's very hard to upgrade versions. This is just a disclaimer. In our projects, we use an add-on that is called the web compiler to output compiled SAS files. The newer SAS version uses a rule called use instead of our import. This is not important for our presentation. I just didn't want to get caught, I don't know, lying or making things up. We have solved the hard to upgrade problem in a way that we are proud of it. The basic idea is that we add Bootstrap as a front-end dependency using reference, how do you call it, the JSON, references JSON or something like that, a package JSON, sorry. And this Visual Studio automatically downloads the referenced Bootstrap library into the node modules folder, and the site SCSS here references the contents of the node modules here, the SCSS folder. And but before it is allowed to do that, we overwrite the values with our own. So these different we rewrite the different CSS variables, SCSS variables used by Bootstrap, like colors, distances, fonts, etc. So we can choose which, we can also choose which modules we include from Bootstrap to avoid unused pieces of CSS bloating up our website. On the screen, you can see on the left, this is our personal, I don't know, theme, SCSS. These are our rules. This is our own CSS file that we are writing for our website. In the middle, we are using the global SAS file that will load the Bootstrap library using our own values, and then load up our custom CSS from the left, and outputs on the right the results that includes everything that I just mentioned. Of course, I've cut out a lot of code here. It would be Twitter Bootstrap code, but we can note. You should notice that the F1 value and the 0F, 0F, 0F values are taken into consideration, and you can see that our code from the left is also included on the right. Yeah, so the approach I have just described in the previous slide produces the following results. We have a complete CSS file for the page using the colors and the values that we have defined. After checking out the code, dependencies are automatically downloaded by Visual Studio, or you can use command line. Upgrading to a new version means editing the package JSON file and working out the incompatibilities. And the good thing is that minor versions shouldn't even cause incompatibilities. So I think we have efficiently eliminated the biggest drawback of these of using one of these libraries, and I recommend that you do the same. Another version, the above version that I have shown you here, used the use rule to load all the files, to mesh all the files together. But the snippet here is from our own project, and it uses the import rule. This is an older implementation of SAS, but this allows us to define our variable overrides in separate SCSS files or different themes, and this means that each theme can define its own values in their own folders. So we can use the same Bootstrap library. We can use the custom values from different themes, and then we can use a global custom SCSS file of ours. So basically, the only thing that you have to write for your different themes are changing variable values. And this generates different CSS that, again, as I told you, looks the same and looks good in each browser, and also works well in on mobile screens. My biggest recommendation to you is that you should use an ORM in your project. An object relational mapper helps you map your code objects to your database. For example, Entity Framework is an ORM that allows .NET developers to work with a database using .NET objects. Here in this small code snippet, students is the name of the database table. Student is the entity based on this table, and it represents a row from it. This little piece of code adds a new row to the database without using any SQL script. Our own project is database first, meaning that the database was designed first, then the ADMX entity framework model was generated from it. Whether you use database first or code first should absolutely depend on your own situation, but I personally can't imagine using anything else than a database first, because Microsoft SQL Management Studio and its designer helps me a lot. Our project contains minimum of 1,000 database queries, except for some special cases like deleting. There are no SQL scripts in the code. I can't even imagine how hard it would be maintaining that much SQL code. By using an ORM, we can write our queries in LINQ, and after the database changes and the model is updated, the compiler makes sure that everything is correct. In one other project, we used the T4 templates, the mechanism of entity framework, to separate the plain old CLR or POCO objects from the model into a separate domain project. This allows us to reuse the same project and the same generated POCOs through the whole project in all layers, saving us, again, time and complexity. In my opinion, the benefits far outweigh the cons. I don't even know if people are still complaining about performance issues. Some years ago, yeah, they were absolutely doing that. Our performance problems were always caused by our own stupidity. I'm sure that most of you are using Entity Framework, but did you know that there are 3 types of inheritance, official Entity Framework inheritance types? Object-oriented programming. In object-oriented programming, we can use both has a and is a relationships, while in a SQL-based relationship model, we can only use the has a relationship between tables, and there is no support for type inheritance. So there are 3 approaches to represent an inheritance hierarchy in Entity Framework model, and I will talk about them briefly and tell you about my or our favorite. The first one is the table per hierarchy, meaning that there is only one table for the entire class inheritance hierarchy, meaning that the table for base class with all possible, this is a table for the base class with all possible, with columns for all possible descendant children. And there is also a discriminator columns based on which you decide into which type you should cast the database row, the entity. And this is the default inheritance mapping strategy in Entity Framework. Table per type inheritance means that there is a separate table for each domain class. The one table for the base class, one table for each inheriting class, and there is a foreign key towards the base class. Finally, table per concrete class. This approach suggests one table per one concrete class, but not for the abstract class. I will show you in the next slide. So if you inherit the abstract class in multiple concrete classes, then the properties of the abstract class will be part of each table of the concrete class. Here you can see it. If you are taking the billing detail is the abstract class, and credit card and bank account are the, let me deactivate the pen, and credit card and bank account are the concrete classes. This results in a bank accounts database table and the credit cards database table, but you can see that there is no billing details table. And the bank accounts table contains its own 3 columns, but also the number and the owner of the base class. And credit card is the same. There is an owner and number inherited from the base class. Here are two of our concrete examples of table per concrete class inheritance implementation. In my first example, spare parts sale can be added to the collection of other types of sales that need their offer updated, because all these entities extend the IOfferable interface, IOfferable service request interface. All entities in a project can be converted to auditable ones by simply adding the 4 columns to their backing tables and making their entities extend the IOditable interface. This approach ensures uniformity across database tables and reduces the chances of mistakes happening. I only want to shortly mention how we protect ourselves, we as a team, how do we protect ourselves from questions in the form of what happened to this invoice? This question is asked usually asked from us by the client, pointing at towards the database table row. Sensitive information that should be protected from changes in the database in our project is protected by a checksum column that is managed by the .NET code. So in case someone tampered with the values using database scripts, an error is shown on the UI to the admin explaining what happened. Either the operation was done through UI and officially logged, or it was done through SQL code and the checksum is not correct anymore. We use this approach to protect ourselves from responsibility. We mainly use stored procedures to assist us with operations directly on the database, like activating licenses, reactivating sales that we have closed on the UI. We avoid using stored procedures from the code because they hide complexity and their correctness is not checked during compilation. One quick and dirty approach that we often use is SQL code generation using Excel. Let's say that we need to add or update these entries in the database sent to us by a client. Again, let me deactivate the pen here. We do the following. We add additional columns around every column. We insert separators like this with control space to select the whole column, F2 to start editing, and control enter to insert the same value into all cells. And select all these cells from the Excel table and copy them to a text editor. Eliminate tab characters with find and replace, and run the resulting script on the database. Of course, the before mentioned approach should only be used for one-off scenarios, like updating the system's error message descriptions every 2 months. You should build an admin UI tool for all repeatable CRUD operations. I recommend you to use TypeScript. TypeScript is a strict typed superset of JavaScript developed by Microsoft, and its biggest benefits are static typing and code hinting. To start using TypeScript, you should simply rename the JS extension to TS because all JavaScript code should be valid TypeScript code. There is a big asterisk here, but I will not go into details now. So, but saving a JavaScript TS file in Visual Studio will automatically generate a JavaScript output, so it's very, very easy to use. Our project has around 72,000 localized items, around 6,000 items in 12 languages, some of which still have to be translated, some of which will never be translated, some of which should always use the English version. And writing an application that bulk manages these translations was a no-brainer. Its biggest feature is that it is capable of exporting all localizations into a single file, and after the translators are done with it, it can integrate it back. There are tools like this that help us with this on the market, but a decade ago, none of them were fit for our needs. Talk about irreversible evolution of software. We also have a separate application for alphabetizing our settings and config files, one to assist us with release tasks, replacer tool helping us with processing the VUEPRESS generated code, as I have mentioned before. And as you can see, we use a lot of internal tools. Here are some conclusions that we have arrived to while creating and using all these, all of them. Write a tool for every possible repeatable task. Make sure that the tool does not require maintenance. If the tool requires maintenance, then look again. Make sure that you find look harder and try to find an existing solution that is maintained by someone else, so you don't have to maintain it. And my favorite rule is that you should always use Windows Forms by default when implementing these small tools instead of a command line. Instead of a command line project. Of course, you should use the Dragonfruit NuGet package to manage command line arguments using the main method only. Windows Forms have very little overhead compared to command line types of projects. They should support headless mode, of course, when needed. And a Windows Form project is Windows Forms application is easier to be handed over to someone from maybe marketing or accounting for to be used than a command line application together with documentation. We have arrived to the unit testing part of my talk. I admit that we are not doing a very good job with unit test coverage on our project, but this does not stop me from offering you some lessons learned. However little time there is, make sure that you're still creating unit tests. Think about it, you're creating a robot that immediately tells you if you make a mistake in the same code in the future, so it's basically working in your place. Make sure that you create at least a tiny test. Also make sure that unit tests are maintainable. If a unit test is hard to maintain, it will sooner or later be commented out. Also, try to extend a newly developed test to other cases as well. For example, besides testing only one web page, you should bulk test them all. If one test that you wrote can be easily used for another use case, then immediately use it and and use this opportunity that you have just discovered a new functionality and profit from it. When we have discovered that we are repeating some manual tests, and those tests take a lot of time, we started looking for ways to automatize them. We have created special unit tests for this that check the source files of the project for example, unused localizations, correct control associations, input validations, etc. We have also extended our integration tests to go and check every page for broken links or exceptions. For the first types of check, like control associations, we of course could have written linters, but we don't know yet how to. So unit tests were the cheapest, fastest solution, and that is what we are all about here. Surely many of you know that it's hard to write a piece of software that does financial stuff right. You know how volatile these processes are. Each day the design changes. Each day in production problems arise. So therefore I recommend a state machine for such cases. The only one that we are, the library that we are using is called STATELESS. And these state machines offer a variety of functionalities, but their biggest benefit is allowing you, or rather forcing you, to define all the stages of your process and events that provoke a transition from one stage to the other. The stages are called states, and these events are called the triggers. They also allow an easy way to verify if the process can transition from its current state to another one. And the state machine definition code in the left, or in the, sorry, on the on the slide illustrates how specific you must be with your state transitions. I will jump over this slide because I'm running out of time, but it's basically the same definition, but in our own project. And here you can see the state machine in action. It verifies if we can transition from a current state to the new one, and if yes, then it will transition to the new state. State machine-based workflows are very important for any project, especially for us, and this is why we use them. Next, Windows performance counters. They provide a high-level abstraction layer with a consistent interface for collecting various kinds of system data like CPU disk usage. System administrators use performance counters to monitor to check for behavior problems. They are not appropriate for high-frequency data collection for application profiling, since they only update every second. But we find them extremely useful while we monitor our different services. We use the application called a Windows application called Performance Monitor that you can see on the screen to visualize any kind of esoteric information about our services without the need for logging, like number of duplicate data packets, packet composition, parsing errors, and many, many more. In the case of an IoT application, logging isn't even an option. You should know that. The traffic is just too damn high. Performance counters require setup on the computer that the service is running on. This is what the code on the slide does. I will move on to the next part because of time concerns. The last part that I will talk about is about Visual Studio. Visual Studio is a tool that most of us use. We personally, our team, are usually not first adopters, but we'll try anything new that helps us and the project. With our quite large solution, we were struggling with the speed of the interface. Visual Studio 2022 Preview 4 already fixes a lot of my personal speed problems, some of which were based on my bug reports, mainly refactoring speed. Editors and designers seem much faster. In older versions of the interface, the editors were blocked for minutes. Quick Actions, for example, now runs on a separate thread, so the interface is not blocked during data connection. I also recommend that you experiment with the advanced C# options, especially with the inline hints section. I will not waste a lot of time on this, but the idea is that if you have string, and bool parameters for a method, Visual Studio will write you the name of the parameters in line, so you won't match up first name with last name. I was already talking about quick actions, but I want to recommend that you do not use quick actions for refactoring, for renaming. Use F2 instead. F2 transforms the variables under the cursor to have green backgrounds. After where you edit your change, the changes are automatically and immediately reflected, and the rename is done after you press enter, much faster. Another tip I want to offer is highlighting your strings and literals with a bright color. I find that it makes my code visually more mappable. This is how you do it. You go into options, environment, fonts, and colors, choose the literal and very yellow bright color, background color. If you have a very wide screen, try your try setting your tab layout to be left, and this is how it looks, and I really like it. I will jump over this. This is basically me recommending productivity power tools for add-on for extension for Visual Studio, and also recommending CodeMate for Visual Studio. We could not live without it. This extension helps us reorganize and arrange our code in a uniform way. This eliminates the discussions during code reviews and the mental effort that would have been that must have been invested if the code were manually organized. And my last recommendation is that I'm risking that this is obvious for everyone. I recommend that you version your APIs and you use dedicated classes for return values from these version APIs. For example, the use REST v3 entity CS here, it's unimaginative and ugly naming, but hopefully it gets the point across. This approach lets us keep serving multiple versions of clients from the same service. You can release a new mobile app version with the new API requirements, while also supporting apps that were not yet updated from the same service. I'm hopeful that my talk contains something new for you, or at least inspired you to hustle more. I would like to thank the Fortech team and the Codecamp.
Thank you from our side as well. Yeah. For you and for the Fortech team.
Thank you. And I also want to thank my team for giving me
big up for his team. Thank you, Vinci, and thanks for the very practical examples that you shared from your experience. Now, taking a step back, how do you help your team or guide your team to acknowledge that technical debt is existing, and how do you quantify, and then how do you manage it? How do you set up like a strategy or a habit in the team to tackle the technical debt?
I really like the question. The idea is that we all know that the project might not be successful because we are doing this. But it's very easy to say, hey, the project is successful because we were doing this. Hindsight is 2020. So the truth is much less romantic than you think. The idea is that we always look for something, a tip or trick that we can implement in our project, especially that it's 13 years old. We always look for something new to integrate, try, because the technology that we are working is boring and old. So again, we are trying to spice up things. So basically it looks like, hey, I found or read this new thing. Let's try to make it work with our project. And if it worked, oh my God, we are so great. Let's do this again later.
So you're using experiments as a learning tool.
Exactly. So we have modernized every aspect of the project except the core technology, but everything else we tried to modernize. We are using front-end workers. We are using this code generation where possible. Any type of unit test, any type of command line tool. It's its own reward. We make our own fun. Like this.
Vinci, I didn't feel the butterflies in your stomach. I was looking at your last LinkedIn post when you were wondering.
Yes, this
How did you feel during the talk? Because from the outside, it felt really good and very insightful.
I'm so happy to hear that. I'm so happy to hear that.
And we all hope you're wearing pants, but that's the side note.
Okay. Should we do the same?
Well, the pressure went away, especially that this format is very relaxing for me. Instead of sitting in front of 60 people, I only see myself and my slides. So I'm talking to myself. So if I saw maybe 600 or I don't know 13 people staring back at me, it would have been much harder, I imagine.
Okay, although we're looking forward to that moment in time, I mean, when we will have those butterflies in our stomach because we have people in front of us. Yes. So last recommendation for coming from Bogdan. So instead of Excel, he's also recommending this tool. So I like the fact that your talk triggers conversation. You reached the goal.
At least one person was touched by me, and I will check it out as soon as this is over, Bogdan. Thank you.
Okay.
Great. Thanks a lot. And we take a short break, 5 minutes, and we'll get back soon with the next session.